right, we're going to take notes on L'Hopital's rule. So L'Hopital's rule says that if the limit of a rational function, so if we have a numerator and a denominator, if the proportion that it gives us is either 0, 0, 0 over 0, or infinity over infinity, then we could take the derivative of both our numerator and the denominator and find the limit as x approaches c of that, and it'll give us an answer. So it's not the quotient rule. We're just taking the limit of, or the derivative of the numerator and the denominator independently. But we can only do this if our limit gives us 0 over 0 or infinity over infinity. And it works for one-sided limits as well. Yes. So this helps us with what we did in 11.1, because 11.1 we had the limits. So we were able to solve limits by like simplifying and then plugging it in. You can also use this rule too to help you solve the limits. So in example 1, we know that sine of x over x, the limit as x approaches 0, is equal to what? It equals 1. This was one of our rules. But the reasoning, the math behind it, ties us to L'Hopital's rule. So if I were to use direct substitution and plug in 0, when we plug in 0, we would get 0 over 0. The sine of 0 would be 0. When we plug in 0 to the x, we get 0. So we can use L'Hopital's rule. So when we do that, we're taking the limit as x approaches 0 of the derivative of the numerator and the denominator. What's the derivative of sine? Cosine x. And what's the derivative of x? 1. So it'd be cosine x over 1. Now we can use direct substitution and we can plug in 0 into our cosine. So this would be cosine of 0. I'm going to put our unit circle here just so we can see. Hopefully we've done it so many times at this point. Cosine of 0 tells us we look at the x value. So that would be 1. So our limit would be 1. In example 2, first thing we want to do is test and see if we can use L'Hopital's rule. So we can plug in 2 into our numerator and the denominator. We would get 2 squared, which is 4. 4 minus 4 would give us 0. 0 times 4 would be 0 on top. And then we plug in 2 in the denominator. 2 minus 2 would be 0. So we get 0 over 0. So we can use L'Hopital's rule. So let's take the derivative of the numerator and the denominator. So I'm going to rewrite it down here. We've got the limit as x approaches 2. Before I take the derivative, I want to rewrite this. So I'm going to distribute the 4 just to make it easier. That way we don't have to worry about whether we're doing the product rule or quotient rule. I'm just going to distribute, simplify it first. So 4x squared minus 16. Our derivative of our numerator would be what? 8x. And what's the derivative of the denominator? 1. So when we plug in 2, what do we get? 16. Awesome. So that would be our limit. So you could also solve this if we think way, way back to chapter 3, I think it was, when we first started talking about limits. We could factor our numerator. So this would be 4 times x plus 2 times x minus 2 over x minus 2. These cancel. Then we could use direct substitution and plug in 2. So when we plug in 2, we would get 4 times 4, which would also be 16. So this is how we learned how to do it way back when, but now we have a new rule. We can use L'Hopital's rule and get the same answer. Let's look at example 3. So first thing we want to see is, can we use L'Hopital's rule? So when we plug in 0, what's the cosine of 0? 1. And then we would plug in 0 in the denominator, we'd get 0. Can we use L'Hopital's rule? No, can't use it here. So it doesn't work. But we still could find our limit here. We can split this up. I'm going to split it up as the cosine of x times 1 over x. We'll find the limit of each one of these separately. We just said, what's the cosine of 0? 1. Go back to the unit circle if you need to. We're looking at the x value for cosine, so that'd be 1. And then the limit as x approaches 0 from the positive direction of 1 over x. We got to think again way back. I think this was chapter 3. Let's think about, what does our graph look like for 1 over x? Kind of looks like this. So what would our limit be as x approaches 0 from the positive direction of 1 over x? Positive infinity. Perfect. So we have 1 times infinity. What do you think 1 times infinity is? Infinity. Perfect. So that would be our limit. So can't use L'Hopital's rule here. It can only be if you get 0 over 0 or infinity over infinity. So we had to use a different strategy to take our limit. Any questions here? Perfect. Example 4. Let's plug in 0. So what's e to the power of 0? 1. And 1 minus 1 would give us what on top? 0. And 2 times 0 would give us 0 in the denominator. So we have 0 over 0. Can we use L'Hopital's rule? Yes. So we're going to use our rule. We have the limit. As x approaches 0, we're going to take the derivative of our numerator into the denominator. What's the derivative of our numerator? E to the power of x. Perfect. What's the derivative of our denominator? 2. Now we can use direct substitution. Let's plug in 0. We have e to the power of 0 over 2. And what's e to the power of 0? 1. So this would be 1 over 2, which would give us 1/2. So our limit would be 1/2. So here let's plug in infinity. So the ln of infinity. Let's think about what our graph of an ln looks like. Looks like this. If we were to plug in the x values of infinity, what do you think we would get? Infinity. And then if we plugged in infinity into our denominator, it would also give us infinity. So we have infinity over infinity, which means that we can use L'Hopital's rule here. So I have the limit as x approaches infinity. What is the derivative of the ln of x? 1 over x. Awesome. Over, what's the derivative of x? 1. So it'd just be over 1, which we wouldn't need. So here we're just taking the limit as x approaches infinity of 1 over x. You can think about this a couple different ways. We just talked about what our graph looks like for 1 over x. It looks like this. As we get closer and closer to infinity, as our x values get closer and closer to infinity, what does our graph get closer and closer to? 0. Or you could think about, if we're dividing 1 by a really big number, we're going to get a really small number. So this would be 0. So our limit would be 0. So if we have, just a general rule, if we have a constant over infinity, this will give us 0. So any constant over infinity will equal 0. Let's look at example 6. So first let's plug in pi. I would rewrite this as 2 times sine of x squared, just because it's going to help us when we take the derivative if we do have to, if we can use L'Hopital's rule. But let's find what our sine of pi is. We've got 2 times the sine of pi squared over 1 plus cosine of pi. So I'm going to copy and paste my unit circle here. So let's go to pi. Sine tells us we look at what? X or the y? The y value. So here sine of pi would be 0. 0 squared is 0. 0 times 2 would be 0. Now let's find cosine of pi. Cosine tells us we look at the x value. So our x value at pi would be negative 1. So we have 1 minus 1, which would also be 0. So if we have 0 over 0, can we use L'Hopital's rule? Yes. So let's use our rule. We've got the limit as x approaches pi. When we take the derivative here, I'm going to use this one because it's going to be easier to then use the chain rule. So I'm going to take the derivative of the outside, so that gives us 4 times the sine of x to the first power. Then we take the derivative of the inside, which would be cosine of x. And then the derivative of x would just be 1 here. Over, let's do the derivative of our denominator. What's the derivative of cosine? Negative sine of x. Awesome. If we plugged in pi here, it would still give us 0 in the denominator, but could we simplify this? Anything cancel? The sine x's cancel. So we're left with negative 4 times the cosine of x. Now let's see if we can take the limit of this. So our limit as x approaches pi, we're going to plug pi in. So we've got negative 4 times cosine of pi. And we just said cosine of pi is what? Negative 1. So we go to pi. Cosine tells us we look at the x value. That would be negative 1. So we've got negative 4 times negative 1, which would be 4. All right, let's look at example 7. If we plug in infinity, infinity cubed would still be infinity. And e to the power of infinity would also be infinity. So can we use L'Hopital's rule here? Yes. So I'm going to take the derivative of my numerator and the denominator. What's the derivative of our numerator? 3x squared, perfect. And the derivative of our denominator? E to the power of 2x times the derivative of the exponent, which would be what? So 2e to the power of 2x. If we plug in infinity here, we get infinity over infinity again. Guess what that means? We do it again. We can take L'Hopital's rule more than once. So we can do it again. So let's do it again here. So the limit as x approaches infinity, and we take our derivative of the numerator and the denominator. What's the derivative of our numerator? 6x. And what's the derivative of our denominator? Awesome. 4 times e to the power of 2x. Perfect. If we plug in infinity, we get infinity over infinity again. So what would we do? Do it again. So let's do it again here. We've got the limit as x approaches infinity again. What's our derivative of the numerator? 6 over, what's the derivative of the denominator? 8e to the power of 2x, perfect. So when I plug in infinity, I get 6 over, we'd get infinity in our denominator. What does 6 over infinity equal? Not infinity. What happens if we have a constant divided by infinity? It's divided by 6 by a really, really big number. What do we get? 0. Awesome. So our limit would be 0. So again, remember, a constant divided by infinity equals 0. So first thing we want to do is let's see if we can use L'Hopital's rule. So when I plug in 0, what's the sign of 0? Let's go to our unit circle at 0. Sign tells us we look at the y value, so sign of 0 would be 0. So this would give us 0 minus sign of 2 times 0 would just be the sign of 0, which is also 0. 0 minus 0 would be 0 over 0 minus 0, which again is 0. So we get 0 over 0, which means we can use L'Hopital's rule. So we're going to take the derivative of our numerator and the denominator. So let's just do one term at a time on top. We've got 2 times the sine of x. What would our derivative be here? It would be 2 cosine x. When you take the derivative of cosine, it's negative sine. So then minus, here when we take the derivative of sine, we get cosine 2x times what? Times the derivative of what we're taking the cosine of. What's the derivative of 2x? 2. Over, in our denominator, derivative of x would be 1, minus the derivative of sine would be cosine x. Let's plug in 0 now. So 2 times the cosine of 0, what's the cosine of 0? 1, so that would give us 2 up top, or 2 minus cosine of 2 times 0 would just be 0. We just said the cosine of 0 is 1, and 1 times 2 would be 2. So 2 minus 2 up top, which gives us 0 in our numerator. Let's check the denominator. We have 1 minus cosine of 0, we said, is also 1. So we get 0 over 0. What does that mean? Do it again. So the limit as x approaches 0 now. What is the derivative of 2 cosine of x? Negative 2 sine of x. Perfect. Then we have minus 2 times derivative of cosine of 2x would be negative sine of 2x. So I'm going to make this positive. Sine of 2x times what? We got to use the chain rule. So we take the derivative of 2x. What's the derivative of 2x? 2. So I'm going to multiply that 2 times the 2 that we already had out front, so that makes it a 4 out front. So I kind of did a couple steps in one there. I multiplied the 2 that I already had out front with the 2 from the inside. Over, our derivative of 1 would be 0. Derivative of cosine of x would be negative sine of x, so that would turn this to positive sine of x. Let's plug in 0 now. What is the sine of 0? 0, so that would give us 0 plus 0 up top, and the sine of 0 would be 0 on the bottom. So again, we get 0 over 0. What does that mean? Do it again. So the limit as x approaches 0. Our derivative of sine of x would be cosine of x, so negative 2 cosine of x. Plus, what would our next derivative be of 4 sine of 2x? 8 cosine 2x, awesome. Over cosine of x. Feeling good about this one. Let's plug in 0. What's cosine of 0? 1. So 1 times negative 2 would be negative 2. Cosine of 2 times 0 would just be the cosine of 0, which is 1. 1 times 8 would be 8. So we have negative 2 plus 8 on top. Already a good sign because it's not 0 up top. We get 6. And then in our denominator, cosine of 0 is 1. So 6 over 1 is 6. So our limit would be 6.